Good morning, good afternoon, or good evening. This is Mr. P checking in with you. Today we're going to be doing our guided notes for section 11.4, the volume of pyramids for secondary math 2. So a pyramid, like we talked about before, is a three-dimensional figure with a polygon as its base and triangles as lateral faces that meet at a common vertex. See, they all meet up at this little tip right here. I like to think we mostly have a pretty good working definition of what a pyramid is, but it's always good to know what the specific one is. Now, the volume of a pyramid is really similar to the volume of a prism. It's just that, well, here's what I want you to imagine. If you put a prism around a pyramid, like if you imagined you were going to give somebody this pyramid as a gift, and you put a box around it like that, the pyramid would fill up 1/3 of that box. And of course, the volume of a prism is the area of the base times its height. And so the volume of a pyramid is just 1/3 that amount. Same goes for over here. It's just the only difference is that this one's one of the oblique ones, where you'd have to imagine this fun, tilty kind of prism, which hurts my eyes to look at, so I'm going to go ahead and erase it. The idea is that the same rules apply, except the difference is that the volume of the pyramid is 1/3 the volume of the prism. So in this case, the base is still the B is still the area of the base, and the H is still the distance you would fall if you fell off the tip of that pyramid. I think that happened in one of the Lord of the Rings, right? Wasn't that the one where the guy was like, "Oh no, my son is still alive!" Oh, and I think one of the hobbits set him on fire, like, "Oh," and then he like ran off. Did that happen, or did I dream that? Anyway, he fell the height. Now the volume of a pyramid, let's go ahead and do this. So again, to find the volume of a pyramid, you take the area of the base, multiply it by the height, because that would give you the volume of the prism that fits around your pyramid, like that. What a terrible, awful drawing, but you get the idea. So to find the area of the base, which here is this triangle, the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. So capital B is 1/2 times the base of the triangle. This is just the triangle part, 6 centimeters times the height, 4 centimeters. If you do 1/2 times 6 times 4, you get 12. 12 centimeters squared. So there's 12 centimeters squared in that triangle. Now we multiply that by the height, which is 9. So it's 12 centimeters squared times 9 centimeters. And 12 times 9 is 108 centimeters cubed. Now that is not the volume of my pyramid. That's the volume of the imaginary prism that fits around our pyramid. So in order to find the actual volume of the pyramid, we need to take 1/3 of that. So it's 1/3 of times 108 centimeters cubed. I think it makes more sense to think of that as 108 centimeters cubed, the volume of the prism, divided by 3, which is 36. So the volume of this pyramid is 36 centimeters cubed. Put a box around it, you're good to go. Okay. This one, same story. We could imagine finding the volume of the prism that fits around it, like that. That is way too tall, but what are you going to do? And that the pyramid is going to take up 1/3 of that. So what we're going to do is we're going to take the area of the base, which is 11 meters, times 7 meters, which is 77 meters squared, multiply 77 meters squared times the height, which is 15 meters. And 77 times 15 is 1,155. Now that's the volume of this whole box that fits around your pyramid. And like I've been saying, the volume of the pyramid is actually going to be 1/3 that. So we're going to take that and divide it by 3, which means the volume of that pyramid is 385 meters cubed. There it is. Now this is nice because they actually tell you the area of the base is 27 centimeters cubed squared. So that means that if the volume is equal to the area of the base times the height, the volume, well, 1/3 of that, right, because it's a pyramid, is going to be 1/3 times the area of the base, 27 centimeters cubed, times the height, which is 5 centimeters. That's actually centimeters squared. If you caught that, good for you. And if you do 27 times 1/3, or 27 divided by 3, that's 9 centimeters squared, times 5 centimeters, and 9 times 5 is 45. So the volume is equal to 45 centimeters cubed. And finally, this thing's oblique, but that's okay. We're going to have to assume that this is the height because they didn't give us a little right angle there. I'm going to assume that there is a right angle there. And so the area of the base is 4 feet times 1 foot, and that is 4 feet squared. Multiply that by the height, times 6 feet, and you get 24 feet cubed. Now that is the volume of a box that you could imagine going around this pyramid. And maybe you can kind of see a picture that might help you see how this fits in 3 of them. Maybe not. That actually kind of hurts my head, but what are you going to do? So we're going to go ahead and take 24 feet cubed, divide it by 3, and I believe that's 8. Let me just make sure. Yep, 8. 8 feet cubed. Wow. Okay. Now let's suppose that we're given the volume of a pyramid. A pyramid with a square base has a volume of 128 cubic inches and a height of 6 inches. Find the side length of the square base. So remember, the volume of a pyramid is equal to 1/3 times the area of the base times the height. Now we know the volume is 128 cubic inches, so 128 inches cubed is equal to 1/3 times the base, which we do not know, times the height, which is 6 inches. Let's put some of this together because I can combine my like terms. 1/3 times 6 inches is 2 inches. So I get 128 inches cubed equals 2 inches times the area of the base. Let's get that b by itself. Divide both sides by 2 inches. Inches divide out. That's going to be squared. Then 128 divided by 2 is 64. So 64 inches squared equals the area of my base. Now, since it's a square, the area of the base is equal to some side length times itself. So 64 inches squared equals s squared, where s is what we actually want to know. Take the square root of both sides. Divides out. 64 is 8, which means that the side length equals 8 inches. Notice that the square root of inches squared took away that squared there. So a pyramid with a triangular base has a volume of 18 cubic centimeters. So volume equals 18 centimeters cubed. The height of the pyramid is 9 centimeters. Centimeters is the height. And the height of the triangular base is 3 centimeters. Find the width of the base. That's weird. So let's go ahead and draw this. So you got some triangle here. And we know that the volume of this thing is 18 centimeters cubed. And then the height, I think that's what it's saying is the height of the pyramid, 9 centimeters. And the height of the base, that thing, is 3 centimeters. So let's write this down. So the volume equals 1/3 times the area of the base times the height. But we know some of this stuff. So the volume is 18 centimeters cubed is equal to 1/3 times the area of the base, which we do not know. We know a little bit about, we'll talk about that in a minute, times the height, which is 9 centimeters. Multiply those, and you get 18 centimeters cubed is equal to 3 centimeters times the area of the base. Divide both sides by 3 centimeters. And you get 18 divided by 3 should be 6. I just want to make sure. There you go. 6 centimeters squared is equal to the area of the base, but unfortunately, we need to know what that tells us about the actual triangle. Now remember, a triangle's area is 1/2 times the little b, which stands for the base that we don't know, times a different h that represents the height of a triangle, which we do know. So we're actually going to rewrite this. 6 centimeters squared is equal to 1/2 times the little base, which we don't know, times the height, which is 3 centimeters. Multiply those, and I'm going to get 6 centimeters squared is equal to 1.5 centimeters times the base of the triangle. Divide both sides by 1.5 centimeters. And 6 divided by 1.5 is 4. 4 centimeters equals b. That is, the base of the triangle has a length of 4 centimeters.